Peptide bond formation is really high yield and it's something I go over with almost everybody that I tutor, so here's a quick rundown of how that happens. We have two amino acids here, and the lone pair on this nitrogen is going to attack the carbonyl carbon on the other amino acid. That's going to push the electrons in one of these bonds up to that oxygen there. So we end up with a molecule that looks like this. That oxygen gets a negative charge, the OH is still attached to that carbonyl carbon, but now we have a new bond between that carbon and this nitrogen. The nitrogen still has both hydrogens, so now the nitrogen has a positive charge, and then we just draw the rest of that amino acid. This bond here is the new bond, and that is the peptide bond. Now what's going to happen is one of these lone pairs on the oxygen reforms the double bond, and that's going to kick off this OH group. And at the same time, the OH group, because it has three lone pairs now, is going to grab one of those hydrogens off the nitrogen. And then the electrons in that bond between the hydrogen and the nitrogen are going to move to the nitrogen and become a lone pair on the nitrogen. So let's see what that molecule looks like. Everything over here looks the same. Now we redraw the double bond for that oxygen, and now it's only bonded to the nitrogen because the OH is gone. The nitrogen now only has one hydrogen on it, so it doesn't have that positive charge, and then we just draw the rest of the amino acid. And notice that what was kicked off was the OH, and then it grabbed an H, so overall we kicked off an H2O, and we'll write plus H2O to show that. And that means that this reaction and any peptide bond formation is a condensation or dehydration reaction. Once again, there is your peptide bond. And then we also need to draw that lone pair that's on the nitrogen. And that's really important because this lone pair can participate in resonance. It can form a double bond between the nitrogen and the carbonyl carbon, pushing up one of the double bonds in that carbonyl carbon with the oxygen up to a lone pair on that oxygen. So let's redraw that now. The left side looks the same, and then now we have a single bond with that oxygen, but it has three lone pairs. And now there's a double bond between the carbonyl carbon and that nitrogen. The nitrogen now has a positive charge. It still has the hydrogen on it, and then the rest of that molecule looks the exact same as before. This is really important because the nitrogen down here has three electron groups, and if you remember from hybridization, that means that this one is sp2 hybridized. The nitrogen above is sp3 hybridized because it has four electron groups. For hybridization states, if you have one resonance structure that's sp3 and then one that's sp2, we say that the molecule is sp2. So the nitrogen in peptide bonds is an sp2 hybridized atom.